In this video, we're going to look at another example of turning a Riemann sum into an integral. So we have limit n goes to infinity 1 over n, root of 1 over n plus root of 2 over n plus root of 3 over n plus dot 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 plus root of n over n. So we start by writing the definition of Riemann sum. That's limit n goes to infinity, summation I goes from 1 to n, f of xi times b minus a over n. This part, b minus a over n, is delta x. And this is equal to definite integral a to b f of x dx. So we have this part here, which is the definition of the right-hand Riemann sum. We take the limit of this right-hand Riemann sum, and that becomes a definite integral a to b f of x dx. That's the definite integral right there. So our goal is to find xi, the x values, the lower limit a, and the upper limit b of the definite integral, the functional values f of xi, and the common width delta x. It's clear that the general term is root I over n. So we can write the above expression in a more compact form. Our goal is to write it in this form: I equals 1 to n, f of xi, delta x. So let's rewrite what we're given. We're given limit n goes to infinity 1 over n, root 1 over n, plus root 2 over n, plus dot dot dot, plus root I over n, general term, plus root n over n. So we want to rewrite this into the form limit n goes to infinity, and we're going to collapse this into using the summation notation. I goes from 1 to n, root I over n times 1 over n. And this here is f of xi, that's the functional values, and this part here is delta x. All right, so let's let xi be I over n. If you let I equals 1, you get x1 is 1 over n. I equals 2, x2 is 2 over n. I equals 3, x3 is 3 over n. In general, I equals n, xn is going to be n over n. That's equal to 1, and that's equal to b. xi is I over n. All right, to find delta x, the easiest way is to subtract two consecutive x values. For example, we can find delta x by just taking x2 minus x1. That is 2 over n minus 1 over n equals 1 over n, and that's delta x. More generally, delta x is equal to xi minus xi minus 1. That is I over n minus I minus 1 over n. That works out to the same as above. That's 1 over n. That's delta x. Now, we know that delta x is equal to the difference between the upper and lower limit, b minus a over n, and that's equal to 1 over n. So we can equate the numerators. B minus a has to be equal to 1. So b minus a is equal to 1. But we already determined that b was 1. That means a has to be 0 since b is equal to 1. All right. So now we have a is 0. We have b equals 1. We have f of xi is equal to root I over n. And I over n, that's just the x values. So that's equal to root of xi. That means we have the function that we're going to use for the definite integral. That's f of x is equal to root x. All right, so let's turn the Riemann sum into a definite integral. Limit n goes to infinity. I goes from 1 to n. F of xi, that's root of I over n times 1 over n. This is f of xi. These are the functional values. 1 over n, that's delta x. That's equal to integral from 0 to 1 root x dx. So let's look at the big picture. What is the big picture in this process? What we have is we were given limit n goes to infinity 1 over n root 1 over n plus root 2 over n plus root n over n. We wrote that in a more compact form using summation notation and realizing the general term is root I over n. That's summation I goes from 1 to n root I over n times delta x of 1 over n. That's equal to limit n goes to infinity summation I goes from 1 to n root xi times delta x. And we turn that into a definite integral. That's from 0 to 1 root x dx. So let's actually draw a diagram for this definite integral. What we really have is a function y is equal to root x. There's our function y equals root x from 0 to 1. And here's y equals root x. We're basically finding the area under the curve below y equals root x and above the x-axis from 0 to 1. And that is what a definite integral 0 to 1 root x dx represents. It represents the shaded area. All right, thanks.